Hello guys, welcome to today's video. So in this video we are going to implement the system runtime for our state machine. In the previous class we added a balance palette to our state machine. So in this tutorial, in this video, we are going to add the system palette and create a runtime for our state machine. So the system palette is basically a palette that allows our blockchain to function. It carries the block number, the nonce, and some other details that is in our blockchain. So it carries, let's say, the metadata of a blockchain. So different details that you want to, or the block number, the nonce, the kind of transaction that happened. So the system palette takes care of all these details. So to get started, we need to create a new file. Create a new file, say touch source slash system.rs. As you can see, we now have a system.rs file in our code. Alright, so to use our system.rs file, we need some details. If you look at the balance palette here, we have just one item in our struct, in this palette struct, this struct palette. So we only add balance. So it allowed us to transfer from one user to another. So but for our palette, system palette, we need to have up to 2 or 3 details. So let's go ahead and create a palette struct here. So public struct palette. So let's create a field called block number. This block number will keep track of the transactions in our blockchain and assign each transaction a block number. Say block number and let's make it store an unsigned integer of 32 bytes. Say u32, and then we also need a nonce. This nonce is called number used once. It's called number used once. So this nonce is a number that is mapped to the account that carries out a transaction. So remember in the last video we used bitremap to map the account balance to a user. So let's use that bitremap again here to map each account number to the nonce that it carries. It's a bitremap string we unsigned that of it. So before our bittree map can work, we need to import it from the ROS standard library. Let's say use std. We have done this earlier, so it should not be new to us again. Collections bittree map. And then let's create an instance. Let's create a new instance of our system pallets. Let's implement pallets. Public function new. I said it in our last class that you can use any name to instantiate a new struct. Self. They say the self should have a block number of 0 and nonce bittree map new. So what are we doing here? We are trying to instantiate this struct here. So this struct with this function will return the default structure of this struct here. So the default that we want it to return is, say we have a block number of 0. Let's say this is our starting point in our blockchain. We have a block number of 0, and then nonce. This number used once, we will supply it later on. We supply this number later on in so let's see if our project is running. We have not done something that I ought to do, but Rust will tell me what to do that thing later on. Let's see Cargo run. Hello world. All right, so to include this palette in our project, we need to import it in our main.rs here, as we did for balances. Let's say mod balances. Right, we are done with this. Now, for us to make this system palette functional, it's currently not doing anything. So let's add some functions to it. Let's make it functional. So to make it functional, we want to do two things. The first thing is that we want to make sure that whenever we are adding a transaction to our blockchain, our block number increases, and then we can also get the block number of that block whenever we have a new transaction. Right, in our implementation, let's create a public function to get our current to get our current block number. Return a self-reference. We expect it to return an unsigned integer of 32. And then return self dot block number plus 1. So what this is doing is that whenever we have a new transaction in our blockchain, this block number will add 1 to the block number. One will always be added to the block number. So whenever we have a new transaction, it will be the initial block number plus 1, always like that. So then let's increment our block number. Public function increments block number say. So here, this our function. It will be mutating. It's a self-mutating function. That is, we're trying to increase the block number here. Here we are only getting the block number, but here we are trying to increase the block number. So whenever the block number is increased, then this will also be increased. So let's say mutable self then say self dot block number so on. Now our third function that we need here, let's say public function increase nonce. So this is also a mutating function. So let's say mutable self, but here we do one additional thing. For whoever make a transaction and we want to increase the nonce of that person, we need to pass the parameter to this. Let's say we say who, then we reference the account number with using a string, and then return the solution. We don't have any initial nonce before. We don't have any nonce that we want to increment. So let's call nonce here. Let's pass nonce from our pallet struct. Specify u32 is equal to sd reference self dot nonce dot get. So we are trying to get the details of someone. Who is the person? Use who, and then dot unwrap or after that. So we are saying that if you're able to get a nonce for someone, you return that nonce, or else if the person doesn't have any nonce initially, you return something else. Let's say you return 0, as we did for the balance earlier. and then let's new nonce is equal to nonce plus 1. Now let's now insert this nonce to the user. Let's insert this new nonce to for this user. Let's say self dot nonce dot insert for who, say who dot clone then you add the new nonce. Now, so what we are doing basically is that for every transaction that a user sends, we want to increase the nonce of that person, of that user. So here is saying this function should be mutable. Then we are passing the parameter. We are passing the user as a parameter here. Now, the initial nonce should. This is the reference. The initial nonce should be returned here. We want to get the initial nonce for the person, and then if the person does not have an initial nonce, we should return 0 for that person. Now let's now give the person a new number. The new nonce should be, for every transaction, the new nonce for that user should be nonce, the initial nonce plus 1. That is, the nonce should increase. So let's see if our project is still running. Saying previous definition of model balance is a min.ls. Oh, sorry, we are using system, not balances. All right, we are getting another error. Let's say, what's that? System line 13. Public function block number okay. This should return just block number, and then B-tree map, the spelling should be capital letter T. Here again should be capital letter T. Here again. Line 8, implement pallets. What's happening? Nonce 32, number 22. Expected identifier. Okay. I didn't assign this nonce to a variable. All right, our code is running. All right, so let's do some tests for our system pallets. Let's see if the right path. Let's write a test. Say config system mode test. Say function initialize system select mutable system is equal to super pallets new function, and then let's say system dot increase block number. Let's call that function. System dot increase nonce also. Increase nonce for who. Say for list string then let's assert that we have a correct test. So let's get the initial block number for Alice. Or let's get the initial block number for Alice. Let's see assert equal system block number is asserted to be 1. Assert system. Let's get the nonce. Let's get the nonce for who? So for Alice, and then let's say it should be 1 if it does not exist. And then let's say for Bob should not have any. System dot nonce dot get for who for Bob. Let's run our test. All right, our test is passing. So in our test we say that if we are trying to we want to get the block number. We're calling this block number function. So you know that initially we have called increase block number here. So when we called increase block number, we are saying that the block number should be 1. This one will be added initially, will be the initial block number. And then we are saying get the block number for Alice. It's Alice block number should be 1. And then we are saying none for Bob. So if Bob does not, because we not have any system does increase block number for Bob here, so automatically Bob doesn't have any block number in blockchain. So we now have a system pallet, that is a functional system pallet that will track the block number and the nonce for every transaction that is being done on our blockchain. All right, so we need to have a runtime now. So this runtime is the pallet. Let's say is a pallet. So this runtime is the function that would take care of all our business logic. What are we doing here? For the runtime, we will have some field which include the system and balances palette. So we will make sure that these two are well coupled together, so that our blockchain will function more perfectly. So we are trying to couple our pallets together with in our blockchain. So the first thing we need to do is to go to our main.rs. Go to main.rs. So let's create a new struct for our runtime. Public struct runtime. So this runtime we take we'll take our balances palette and our system palettes. Let's say balances. So the type of documents, the type of field will be balances palettes. And then system pallets. So we have been able to expose our balance and system pallets in our runtime. All right, let's create a new runtime. Let's say implement runtime. Let's create a new instance of our balances and system palette. Let's say function new return self. So self should instantiate system palette and also balances palettes. So this will give us a new instance of our runtime, that is in an instance of the system and balances palette. Right, let us try and simulate a genesis block in our blockchain. So every blockchain usually have a genesis block. The genesis block is the beginning of all blockchains. So in our genesis block, you can give a new balance to a user and then do some other things like that. In our main function here, let's create a new runtime function. Let's mutable runtime. Let's go to the runtime palette, new instance. Let's let's give Alice here. Alice is a user. Let's see, that's Bob. And then let's bring a new user. Let's say Charlie. All right, in our runtime, so in our runtime we have called we have linked our runtime to the system and balances palette here. So from this place we can increase the account balance of any user. So let's do that and see what will happen. Let's simulate a new block. Okay, let's set a new balance for Alice first. Let's say runtime dot balances dot set balances for who? For Alice. For Alice, let's give 100, and then let's simulate the block. Let's say runtime dot system dot increase block number. Remember that's function. And then let's assert that our block number is 1. Let's check that our block number is 1. Runtime dot system dot block number let's get our block number, and then let's carry out a new transaction. Let's say runtime dot system dot increase nonce for Alice. Let's check our response. Let's say response is equal to runtime dot balances. Let's get Alice's balances. Okay, let's try to we know we have already given Alice a balance of 100. Let's try to transfer some amount from Alice to Bob. Balances dot transfer from who? Let's say Alice dot clone Alice dot clone to who, to Bob, amount, let's say 40. So we want to check, this is more or less a function. We want to run a function, and then we want Alice to make transfer of 40 dot to Bob. So we need to check if this transaction is successful. We should have it should be successful. If it is not successful, then we want to have an error handling. We want to handle our error graceful. Let's say you can do something like called map error. So here we can say we want to map, if there's any error, we want to map the error, and we print the error on our terminal. Print line, then error. That's the first transaction that we are simulating. Then let's simulate another transaction. Let's say runtime dot system dot increase nonce for who, for Alice again. Alice wants to transfer a lot of money to Bob. Then let's response is equal to runtime dot balances dot transfer to from who? From Alice to Charlie. Let's transfer 20 to Charlie this time around. Then let's undo our error. Let's say error print line. So let's run our code. Okay. So I omitted something. Okay, the name that I use for my function is different from I still have this error, say balances new is not found in system and balances. I think we have new here, and then we have new here also. What am I doing wrong? Cannot find new function. Cannot find function new in module system main.rs line 12. Cannot find module imbalances. So line 12. What's happening? Okay. I think I omitted balances pallets here. Okay, our code is run successfully. So we have been able to increase the nonce for Alice when she makes a transfer to Bob, and we have also been able to increase a nonce when she also makes another transfer to Charlie. So this means that we have a state machine that is working functionally. But also, let's confirm if our transaction is going on fine. We need to print the details of the transaction in our terminal. So to do this, we use a macro called debug. So derive debug. So this macro allows us to implement some traits that evaluates some transactions for us. So this debug allows us to print the result of our transaction in a readable format in our terminal. So let's just implement debug for our transactions. Let's say in our main.rs here, let's implement debug. So it allows us to print a readable format. Our terminal, let's say print line. So in our system file, let's implement debug. And also balances, pallets. So we should find the details of our transaction here. Sorry. All right, let's check our terminal. As you can see, so the new balance uh for Alice is now 40. She transferred 40 to Bob and then 20 to Charlie, and then Alice new block number is 1. The nonce for each transaction is now 2. So our project is compiling very well, and then we have been able to add a system palette to our runtime, and also we added a system palette to our blockchain, our state machine, and also a runtime. So this runtime takes charge of all the transactions that are going on in our blockchain. Thank you very much.